Today we are doing lesson 1-1, day 2, linear equation word problems. And so our objective, we're still going to write and solve one-step linear equations. That hasn't really changed. That's still our goal in this section. Problem-solving plan. We have understand the problem. Okay, what is known? What information is given? What is being asked? We need to know that before we can really start and make a plan. And that's our second one. Make a plan. Decide how you will solve the problem. There may be more than one correct way. All right? There's lots of different ways to do things. Sometimes different methods are pretty much the same steps and there's no benefit either way. It's just beneficial to how you see it and how you solve it and how your brain comprehends it. Sometimes there are not better ways but less time-consuming ways, okay? Like if I wanted to cut my grass, mowing it with a push mower is better than cutting it with scissors. Cutting it with a ride-on mower is better than doing a push mower or scissors. So there's different methods that may save me time, but in the end, I get the same results, okay? And then our last thing, we're always going to solve it, of course, with the plan we come up with, okay? And then, does your answer make sense? With word problems, we can actually put that into like a real life example. If they're asking how many kids are in the classroom and I somehow get like -20, then I could say, well, how could I have negative people? That doesn't make sense, okay? Or if something, I'm trying to figure out how much a watermelon weighs or something, and I get like 1,000 pounds. Well, that doesn't really make sense unless we're talking about like the world's largest watermelon, I guess. But so there's certain clues and kind of things that you can think about in relation to, does it make sense? Is it possible? Okay? So you always want to question that, especially with word problems when you have more context in the problem. There's one formula that we'll talk about today. And so that's right here as well. This is the distance formula. You might have used it before in science, or you will use it in science. You might have seen it before in past years in middle school, okay? But distance, your D stands for distance, which is pretty straightforward, D for distance. Your R is a rate. And that's usually like a speed. Like, you know how cars go, 55 miles per hour? Okay, that's a rate. T, our last one. T is time. And with the distance formula, really you could use any time, so it could be measured in days or hours or minutes or seconds, as long as your rate does the same thing. So I gave the rate example of 50 miles per hour. So my time I would have to make sure that it was also in hours. If it wasn't, then I would have to switch at least one of them because they have to have the same time frame that we're talking about. All right? So on this first guy, we have in the 2016 Olympics, Usain Bolt won the 200-meter dash with a time of 19.78 seconds. Find his average speed to the nearest hundredth of a meter per second. So we're going to find our answer. We'll write it here, okay? So we're going to think of an equation. Well, we have every box this distance. We know how far he ran, right? 200 meters. What else do we know? The time. Very good. We have the time here. And what is the units that they are using for time there? Seconds. Okay, so they're asking us find his average speed. Okay, if you need to write underneath speed, you can write, that's his rate, really. So when we're talking about rate in the distance formula, that's what we're talking about. We're talking about the speed, okay? And they want us to find it to the nearest hundredth. What number is that in our, nearest hundredth? There's a TH at the end. So is that before a decimal or after? All right. So nearest hundredth, we have a decimal point. Is it the first number after? No. Second number? Yes. Good. Okay. So we know we have to go 2 numbers after our decimal point. And then they're saying measured in meter per second. Okay. This is important. Meter matches meter, good. Second matches second, good. We can't use different units of measure or else then we have to convert and it gets messy. So we always want to make sure we're using the same units, okay? So now let's plug it in. We know the distance, so I'm going to put 200 equals, and I'm just copying my formula. Distance was 200, equal sign. The rate, I don't know it. They're asking me for it, so I'm going to leave it as R. And then my time is 19.78. Now, when I'm writing an unknown letter times a number, do I usually put the letter first or the number first? The number. So we're going to rewrite it so that number is first. So 19.78 R. That's how we represent multiplying a number that we know with a number we don't know, a letter, a variable, okay? So this is my equation. So how do you think we can solve it? Yeah, awesome. That's what you guys did last week, right? Friday. If we're trying to isolate that variable, we can divide by that 19.78. Okay, because we want the R by itself. That's how we're going to figure it out. So then we can divide 200 by 19.78. All right? These cancel out not because they're 0, but because they became a 1. But do I have to write 1R? No, I just write R. And remember, we're going to round it 2 decimal places. Look, so my long decimal that I got was 10.11122346. Okay. And mine may have gone more numbers than yours, but that's okay. Every calculator is slightly different depending on their screen, how many numbers can hold on their specific calculator screen, okay? But I'm going to round this off because they told me to. So I'm looking at that second number in. I'm going to zoom in here, okay? So there's 3 ones. I'm looking at that guy, but I have to look next door to see if, hey, is it going to stay 0.11 or are we rounding this up? Okay, and what's the answer to that? Stays, yeah, okay? So our final answer, I'm going to write it over in our answer block, is going to be 10.11. And now this is an average speed. What was the meters per second? Yes, good. Awesome. You can write meters. Yes, meters. I'm going to go under per second. Okay. If you wanted to abbreviate and write M/SEC, that's totally fine. Okay. There's lots of different ways to represent meters per second. Okay. Just like miles per hour is MPH. Okay. That's a common one. That's kind of abbreviated. Same deal here. All right. Did we answer our question? Yeah. Does it make sense? Yeah, he can. I mean, he's an Olympian. I couldn't run that fast, but I'm sure he can. All right. If we plugged it back in, just did a quick check, even if it's just very basic. If I just did 10.11 times that 19.78, do we get really close to 200? Because remember we rounded. So will it be exactly 200? No, it may be a little bit off, just slightly. It shouldn't be way off. It should just be slightly off, okay? And that's how you can check real quick. Just plug it back in like we did last week. Is it? Perfect. 199.975? 85. So super close, all right? And that's because we rounded it a little bit. That's why it'll be slightly off. All right, let's check the next one. We have in 2015, a vehicle drove from the Golden Gate Bridge to New York City. Does anybody know where Golden Gate Bridge is? Yeah, so they drove from the West Coast all the way to the East Coast, okay? At an average speed of 15.7 miles per hour. Not very fast, huh? The journey took 9 days. Does that make sense? If he's going that slow, I could definitely see it taking that long. Estimate how far the vehicle traveled. So again, they're asking us to estimate, round. Are they specifically telling us what number to round to? No. So if we all did this separate, could we have maybe slightly different answers depending on what we all chose to round to? Yeah, okay. So we're going to do it together, though, so it shouldn't be too off. So let's see. What do we got? We have, what do we know? We know that they had an average speed of 15.7 miles per hour, okay? We know it took them 9 days. We are being asked how far. So we don't know the distance, okay? That's the how far part. We do know the time is in days, and the rate, aka the speed, is measured in miles per hour. Do you see how hour and days are not the same unit of measurement? So we have to convert one. It's probably easiest to convert the 9 days. How many hours are in a day? 24. So let's just multiply 9 times 24, and then we'll get that hours, okay? 216, perfect. Let's write hours underneath that 9 days, okay? Because remember, we need the same units. That's the big thing, all right? Always look to make sure they're the same. So now we're going to use that formula again. D was our distance. We don't know it, so it's still D. R is our rate. We do know that. It's 15.7. And we could abbreviate it as MPH, miles per hour. And then our days, we converted it to hours. And so we have times, I'm going to put a dot for multiplying, okay? Times 216 HR for hours. So let's multiply it, right? Our D is already isolated, so I actually don't need to do anything except for multiply these together. All right. Awesome. So D equals 3,391. Again, there was a 0.2 here, but we're choosing to round to the nearest whole number, so we could just leave it as 3,391. And then is it going to be miles per hour still? No. What is it going to be? What unit? Just miles. Yep. You can write out the word miles. You can write it with MI for miles. That's the abbreviation. And we'll write it over here. 3,391 MI. Okay? How many of you guys, have anybody ever driven like kind of far away, cross country or half cross country? Is that about right, you think? Yeah? I have driven to New York because I'm from there. So from here to New York is, it's almost 1,500. So yeah, that kind of is reasonable. That makes sense in my head. If we doubled that, it's 3,000 something. So kind of makes sense. All right, if we plug it back in, it should work too, okay? All right, this guy here, on January 22nd, 1943, so way back when, before you guys were born, before I was born, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? So what do we know? The time, good, 9 a.m. Oops, sorry. There we go, 9 a.m. And then 9 a.m. to what other time? Good, so how many minutes has passed? 27 minutes. So in 27 minutes, do we know what temperature we started with? Yeah, how much? Good. And what temperature did we end with? -4. So, ideas. How much did it drop? They want to know, right? What is it? 58? Good. How did you do that? So what did you add?
54 plus 4.
54 plus 4. And we got 58. Did anybody do something different? Why not -4? Why don't we do 54 minus 4? I think you're on the right track. So what does the word drop mean to you? Would we add or take away if it drops? Subtract. So you're on the right track. I feel like you were right there. If I had 54 minus -4, doesn't that mean the same thing as plus? So your brain just jumped to it. That's perfect. That's exactly what we needed, right? If you need more of a visual, some of my students like visualizing it. If I'm here at 54 and I went all the way down to -4, well, all the way to here brings me to 0. Sorry, I'll go a little bit further. All the way to here brings me to 0. And then if I take 4 more away, And that still gets me 58. So lots of different ways. Draw out pictures if that helps you. However way you see it, as long as it's mathematically correct, I don't care how you solve it, okay? So that was simple. Temperature dropped 58 degrees Fahrenheit. And they were both measured in Fahrenheit. If one was Celsius, we'd have to do a whole conversion and be messy. Ooh. Don't worry, we'll do some conversions with those, just not yet, okay? And then, yeah, I mean, that's reasonable. That's crazy. That's 27 minutes to drop that much is kind of insane. Probably in the world record somewhere. All right, last guy. You thought the balance in your savings account was $68.33, but you forgot to record a withdrawal. Your statement lists your balance as $26.33. How much was the withdrawal that you forgot to record? Yeah. So what can we do with what we know versus what we need to figure out? Yeah, subtract. Awesome. All right, so take 68.33, right? $68.33 minus your $26.33. And what does that give us? 42? Awesome. So we forgot 42. If I plugged it back in, right, check it, makes sense. So our next page is blank. At the top it says scrap paper for homework, skills trainer, extra problems. You can use this for homework, okay? That way it's all together. All I ask is that if it's number 1, you write number 1, you show your work, and then you can choose to box it. That way it doesn't like bleed into other questions. Just working on that expectation of staying organized, keeping track of it. If you're like, hey, I really don't like the blank paper, I prefer to write in my notebook on lined paper, totally fine. You do not have to use this paper. I just offered it just in case people needed it and they liked it right behind their notes, okay? But you do not need to use it. I do want you writing your homework somewhere so you can ask me questions, all right? So